Hello everyone, in this video I'm going to explain you the most important questions from chapter Gravitation. And if you are a class 9 student, you should definitely watch this. So let's begin. From the exam's point of view, these are very much important questions. So make sure to watch the video till the end. Now here is the first question. Define uniform circular motion. Motion of a body with constant speed in a circular path is called uniform circular motion. So there has to be a constant speed in a circular path. Then only we can say that the body is in uniform circular motion. Who formulated universal law of gravitation? Sir Isaac Newton. He formulated universal law of gravitation. Third question. What is the value of universal gravitational constant? 6.7 into 10 to the power of minus 11 Newton meter square kg square. This is the value of universal gravitational constant. Define centripetal force. It is a center-seeking force. The net force which can change direction of the velocity of a body is called centripetal force. So the net force required to keep the body in circular motion. Fifth question is define free fall. An object is said to be in a free fall when its motion is purely because of the action of gravity. No other forces are acting on it except gravity. So when an object falls down towards the center, when an object falls down towards the earth under the gravitational force alone, we say that the object is in free fall. What do you mean by buoyancy? The upward force experienced by an object when it is immersed into a fluid is called force of buoyancy. It acts in upward direction and it depends on the density of the fluid. Weight of a body can be measured by spring balance. So the weight of a body can be measured by using spring balance. Here is the eighth question. What is a weight of a body of mass 10 kg at center of the earth? Well, we already know weight equals to mass into acceleration due to gravity. Here we need to find the weight of a body and the mass given is 10 kilogram. So weight equals to 10 kilogram into 0. Here the acceleration due to gravity becomes 0 at the center of the earth. So 10 into 0 equals to 0. Here weight is 0. Give the value of capital G, the value of universal gravitational constant as arrived at by Henry Cavendish. The value of universal gravitational constant G as arrived at by Henry Cavendish is G equals to 6.7 into 10 to the power of minus 11 Newton meter square kg square. Define center of gravity of a body. The center of gravity of a body is simply the point where total weight appears to act. So till here, are you able to understand? Alright, let's move to the next question. Now here are the numericals. We will be solving this. An object is dropped from a tower 180 meter high. How much long does it take to reach the ground? Here we have to find the time. So we already know initial velocity equals to 0. Height is 180 meter. G equals to 10 meter per second square. Now h equals to ut plus half into gt square. This is the formula we'll be using to solve this problem. 180 equals to, here height is 180. So 180 equals to 0 into t plus half into 10 into t square. Here 0 into time equals to 0 and half into 10. 2 ones are 2 fives are. Here 2 is cancelled. 180 equals to 5 into t square. If we take 5 to this side, 180 divided by 5, we get 36. If we square this 36, the time will be 6 seconds. So the object which is dropped from a tower, it takes 6 seconds to reach the ground. Now let's solve another problem. A car driver increases the speed of a car at 10 meters per second for 5 seconds. Find the maximum speed of car if its initial speed is 10 meters per second. We already know the initial velocity of car, that is 10 meters per second, and the acceleration is also 10 meters per second. Here the given time is 5 seconds. Now we have to find the final velocity of the car. So for solving this problem, we will be taking a formula, that is V equals to U plus AT. In the place of U, we will be writing 10 and the acceleration is also 10. Time is 5. Now after further calculation, we get 60 meter per second. The maximum speed after 5 seconds is 60 meter per second. State and derive the universal law of gravitation. Previously, I had explained these concepts, the derivation of universal law of gravitation and the derivation of acceleration due to gravity. So to understand better, you watch these videos. There is a link in description, so you can check it out. If you have not subscribed to my channel, consider subscribing. Also share it with your friends. But for now, let me tell you in short. State and derive the universal law of gravitation. According to universal law of gravitation, every mass in this universe attracts every other mass with a force which is directly proportional to the product of two masses. That is, F is proportional to capital M into small m and inversely proportional to the square of the distance between them. That is, F is proportional to 1 by d square. So let's take this as equation 1 and equation 2. Now F is proportional to capital M small m upon d square. Now if we remove the proportionality, we get F equals to capital G M small m upon d square, where G is constant and is known as gravitational constant. Its value is 6.7 into 10 to the power of minus 11 Newton meter square kg square. G is called universal gravitational constant. State and derive the acceleration due to gravity. When a body is dropped from a certain height, it falls with a constant acceleration. This uniform acceleration produced in a freely falling body due to gravitational pull of the earth is known as acceleration due to gravity. Now let's derive acceleration due to gravity. We already know F equals to capital G M small m upon r square. Now what is the second law formula? F equals to ma. Ma is equals to mg. Now mg equals to capital G m small m upon r square. We get this from equation 1 and equation 2. Mg equals to capital G m small m upon r square. If m is cancelled, G equals to capital G m upon r square. Now let's move to the another question. Now here is the numerical. A person weight 110.84 Newton on moon, whose acceleration due to gravity is 1 by 6 of dirt of earth. If value of G on earth is 9.8 meter per second square, then calculate value of G on moon, mass of a person on moon and weight of a person on earth. Now here the weight of a person is given. So we have to calculate this A, B, C. Here to calculate this all, first we will be starting with a value of G on moon. The value of G on moon is 1 by 6 and acceleration due to gravity on earth is 9.8 meter per second square. So G on earth into G on moon. Now this is equals to 9.8 into 1 by 6. After multiplying this, we get 1.63 meter per second square. Now we have to find the mass of a person on moon. Now we already know weight equals to mg. Here weight is 110.84 and the value of g is 1.63 meter per second square. So m equals to, so here weight equals to m into g. After further calculation we get 68 kg. So the weight of a person on moon is 68 kilogram. Now let's find the weight of a person on earth. Weight equals to mass into acceleration due to gravity. Here mass is 68 kg and acceleration due to gravity is 9.8. After multiplying we get 666.4 Newton. Let's move to the another question. What is weight? What is the weight of a steel ball of mass 1 kilogram? Weight means the force of attraction on the body due to earth is called weight. So the gravitational force by which earth attracts an object is called weight. We already know weight of a body equals to mg. Here mass is 1 kg and acceleration due to gravity is equals to 9.8 meter per second square. So weight of 1 kg of steel ball is equals to 1 into 9.8 Newton. That is equals to 9.8 Newton. So the weight of a steel ball of mass 1 kg is 9.8 Newton. Differentiate between mass and weight. Mass, the total quantity of matter contained in an object, is called mass of an object. The gravitational force by which earth attracts an object is called weight of the object. Mass does not depend on g, while weight depends on g. Mass of an object can be measured by its inertia. Weight equals to mass into acceleration. Mass of the object remains constant at all the places, while weight of the object is different at different places. SI unit of mass is kilogram and SI unit of weight is Newton. Mass is a scalar quantity, weight is a vector quantity. Mass can never be equal to 0, weight can be equal to 0. So the question difference between mass and weight, this is a 3 marks question. According to exam's point of view, this is very much important. Let's move to the another question. What do you mean by acceleration due to gravity? When a body is dropped from a certain height, it falls with a constant acceleration. This uniform acceleration produced in a freely falling body due to gravitational pull of the earth is known as acceleration due to gravity. So whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to the earth's gravitational force. Therefore, this acceleration is called acceleration due to gravity. It is denoted by g. The unit of g is the same as that of acceleration due to gravity, that is meter per second square. What are the applications of universal law of gravitation? This is also a 3 marks question, so revise it. The universal law of gravitation plays a major role in physics. The universal law of gravitation demonstrates the movement of the planets around the earth. It describes how all the planets are rotating in their orbit by balancing. According to this law, all the bodies in the universe are influenced by the gravitational force. This law is also important for demonstrating the various natural phenomena like rainfall and snowfall. It also explains why water from the rivers is always in the downward direction. Along with this, it also demonstrates why rivers flow continuously in the forward direction. This law helps in the discovery of new stars and planets. This law explains why artificial satellites stay in the orbit around the Earth.